Greetings, geologist. If you are one of those students who missed this field trip, I would like to go back and have a review. I've decided to post up some key points about what we did when we walked the MCC Marina Lover's Leap walking trail that goes to Cameron Park. So if you did miss that or want to hear some more information, that's what this is designed to do. So first and foremost, the river we walked by was the Bosque River. There's actually three segments of rivers that feed into Lake Waco called the North Bosque, the Middle Bosque, and the South Bosque, respectively. The North Bosque contributes about 75% of the actual flow into Lake Waco. South Bosque comes in number 2, and Middle Bosque, that comes out of the Crawford area, contributes the least amount of water. Once the water flows through Lake Waco's dam, south of the dam is where you saw the river segment that we walked. That's actually the only river segment of the true Bosque River. So interesting about that, it's only about 3 river miles long, and then it has the confluence with the Brazos River. So to find confluence, that's where 2 rivers join, or 2 tributaries, into one. And so that happens just downstream of where we walked. So as we walked along the pathway, I showed you some important things. And a couple of notes for those of you who weren't there. We talked about biological weathering, physical weathering, dip, which is the angle of the bed of rocks out there. Most of the bedrock looks like this, it's straight up and down. And so that it definitely contributes to mass wasting. We definitely talked about mass wasting, and I'm fixing to get more into that and show you some shots from our video and some actual video that we took while we were out there. So FYI, this is about marine transgressions, and to define what a marine transgression is, that's a sea level rise. The big question is, how big of a rise? That's a hard one, especially considering that the depositional environment that we see out there at Lover's Leap represents lagoonal muds, which would be the clay or the shale that you see, which was the paper thin layers, versus the blocky rock stuff that was white, that was limestone. There wasn't that big of a difference of distance from the shoreline, just enough for sea level rose, probably by anywhere from a couple of feet to 20 or 34 to 40 feet, and then back down over a period of time. So how long did that actually occur? For the last half of the Cretaceous, for sure. So it's a very important time frame when we're looking at this particular rock layer, because it is such an important depositional environment, showing us alternating sea level rises and sea level drops. When we call a sea level drop, that is called a regression by definition. So let's get started. I'll see you at the end, and we'll conclude then. So you are looking at a section of the trail that we stopped and looked at, and this is where a mud crack has actually developed into a serious mass wasting problem. What happened was, starting about 2 years ago, this began to separate, and due to the rainfall that runs off from campus, you can actually see where it drains down there. It's been eating away the fabric of that rock, and since the rock is based out of calcium carbonate, it's subjective to karsting and dissolution. So that's what's been happening here, and then you see evidence of biological weathering all throughout it with plant roots and tree roots. That's another factor that plays into this section being eaten away. So I'm guessing that probably in the next 6 months to a year, this thing's going to be completely fallen off into the bosque. So we took a look at this, and then I told the quick story that this is going to eventually exceed the angle of repose. That would be like Coyote on Saturday morning waiting for Roadrunner to run by, and he's got a rock at the top of a mesa and gonna squash old Roadrunner if he can, and the very last second he realizes that the entire mesa wall is breaking off because he weighs too much with the rock, and everything goes smashing to the bottom of the hill. Well, that's what exceeding the angle of repose does. It actually exceeds the actual weight that a rock or some kind of earthen material can sustain, and once it exceeds that point, it drops off. So that's probably what's going to happen here, and it's already beginning to happen here. When it finally does, it'll be quick. All right, we'll go to the next place. See you at the next stop. Squish on to where you can see right where Jake is. Jake, put your foot on the paper thin layers. Further down. Do y'all see that gray stuff he's put his foot on? Do you see how weak it looks? And notice that it's really thin laminate layers of clay. Clay is all about the size of detrital clast, right? Less than 0.002 millimeters in diameter. Can you see why a geologist might draw that as dashes? Totally makes sense, doesn't it? Directly above it, put your foot on where it looks kind of whitish. That's called a conformable contact. Above his foot is where limestone is, white stuff, okay? Don't confuse the color with what type of rock is there. Look at how the rock texture is. The limestone is much, much harder than the shale. So here's why all this debris is here. This was not just a slow episodic event. This was a rapid mass wasting event. So here's what happened. If you can imagine, all these boulders are stuck at the top of that section right there. Now I want you to think about why it's so smooth. We had a sheer face of this entire cliff literally slide right off. It was a big giant rock slide is what it was. And this event happened not once, not twice, but 3 times over a period of 2 weeks. We had a substantial amount of rain that occurred over the time frame of like November, December-ish time frame. And this whole thing got filled up with too much weight of water. And when it did, the whole thing slid right off in an instantaneous event like that. Now, I showed you some fossils as we came in. Here's a really great fossil right here that I got my hand on. Can y'all see that right there? There, let me get it rolling. All right, so clams got about this big in the Cretaceous. So if you can imagine the shells, the top and the bottom piece getting up to that size, you have everything from little tiny ones to gigantic Mongo ones. So the real thick fossils you find in here that are about this thick are usually one of 2 types of fossils. They're either big giant clams or they're bryozoans. And you'll learn about both next week, or certainly by the time we get to fossils by the end of next week. Okay? And so you're going to examine that, and I want to ask you, do you think that could change the structural integrity of this formation if I got a lot of that growing in, or that's in the rock, and we get a fracture where that is? Do you see how that could cause a problem? Okay, so that structurally could be a bad thing. Something else I might point out is you can really look at the limestone blocks up there and see how they're blocky and look like bricks. That's really important to the story out here because limestone is karsting out here, which is one more problem. So this thing has like a dozen different problems going on all at the same time, being very conducive to mass wasting. So I'm going to ask you guys, do the blocky limestone represent a rise or a fall in sea level? You're not sure. Half of you said rise, half of you said drop. Which one is it?
Shale comes when there's a drop.
Shale would be drop because it's going to have more detrital stuff, meaning the coastline is, or closer to the coastline, where you're going to have more stuff coming in and flooding in from runoff from the coast. Limestone, this is pure limestone, folks. This is as pure limestone as you'll ever see. Chalk is almost 100% dead animals. That's what it is. Baby tiny foraminifera. I was telling somebody, Christina said she filled her car up yesterday and she was saving gas by walking today. And I was like, well, you need to thank your car for foraminifera. She just looked at me like, really? Foraminifera are microscopic animals that contain a little bit of oil in their bodies when they were alive. So as these things die, they accumulate at the bottom of the ocean into big layers, and as new rocks get put on top of them, it compresses the oil out of their little tiny bodies and makes hydrocarbon deposits. But you got to have gazillions of them to do that as they all die off. So the big blocky layers are harder, and then now can you see the thinner layers of shale in between? So humor me and count from the top down how many times you think this has gone sequence change, like it's gone from lagoon to more marine settings. And you don't have to give me a perfect number. Give me an estimated number. Trust your gut. You can count.
Counted 30.
At least.
Yeah. 25
to 40. Somewhere in there is the right number, depending on how many you counted from which direction. What I'm telling you is that almost the entire Cretaceous period is documented right here in this rock formation. And you're getting deposition over a course of about 60 to 80 million years. And this represented a change in sea level right here at MCC campus at Lover's Leap dozens of times, where sea went up, it went down, it went up, it went down, it went up, it went down, it went up, and went down. It sounds repetitious. The rocks prove it. So what we're missing here is the beach line in the nearshore environment. If you went further in to Texas, like West Texas, you would find the matching rocks from this age that were the beach line and the nearshore environment. All right, welcome back. So we've just taken your virtual field trip to the MCC Marina, and hopefully you noticed those alternating layers that we looked at. Very important because they represent alternating changes in sea level. So I need you to remember that limestone represents a rise in sea level and the shale represents a slight drop. Somewhere else in the state of Texas or further inland in the United States should be the matching shoreline and nearshore environment. So I'd ask you, what rocks would those be? You need to think about that, and it'll be on your question sheet that you're having to answer. Thanks for joining us today, and we will see you at the next stop. Bye.